Okay, we're asked to find the vertex of a given parabola using a derivative and algebra. So let's go ahead here and grab our equation for our parabola, which is going to be f of x is equal to x squared plus 8x plus 2. Now give me 1 second, I just want to make sure that I wrote that down right. X squared plus 8x plus 2. Okay, good. So if you know what a parabola looks like, and by the way, parabolas are really beautiful shapes. And when I say that, um, you should take a moment and Google, okay, Google parabolic solar reflectors. Or just do it on YouTube. There are people out there that have built these little mini dishes. You can think about it like your satellite dish in your house, where the feature of a parabola is that as light enters, it bounces to what we call a focal point. Okay, everything that enters bounces to that focal point. And so you'll see videos of people who have created little dishes and they can cook things on them, or it gets so hot you can light paper or wood on fire. I mean, it's really a neat mathematical geometric property here. So the parabola we know looks like a U. So this guy right here we know looks something like this. We know it's up to, we don't know which way it's shifted necessarily, but we just know it looks maybe something like that, okay? And it has some vertex value. Now, who knows exactly where it is? That's really what we're trying to find, right? We're trying to find this vertex. So what we're going to do is we know that for a given parabola, okay, we know that at its base, at the bottom, at its vertex, okay, that if we draw a tangent line in there, it's horizontal. That's the one of the key things about the vertex is that it's the minimum or a maximum, depending on this one's going to have a minimum because it's opening upward, but it could be a maximum. Okay, so we want to find that vertex, and the key is that the vertex, so let me write this down for you, and you should have this memorized or written down in a book or tattoo it on your arm, whatever you have to do to remember it here. If you do tattoo it on your arm, send me a photo of that. I would love to share that with everyone else. So here's the idea. The vertex, that is where the slope of the tangent line is 0. And so the tangent line itself is horizontal. Now we'll be using that idea in later sections when we're trying to find minimums and maximums of functions that aren't necessarily parabolas but are other polynomial type functions. Okay, so what we have to do is we have to find the derivative of this guy. Now I understand there's some really easy shortcuts. We can use the power rule here, but that's not part of this section, and you need to be able to, on your test, demonstrate that you can also do this problem in this manner, okay? Even though you can check it with the power rule if you've already taken a calculus course. So we need f prime, okay, at some point, some x value. Well, there's two ways we can do this. We can use the quadratic rule that we're given, which is one of the ways that I'm going to do it here, or we can do it all out by hand. So I'm gonna first start it out by hand. So this is going to be f at x naught plus a little bit minus f at x naught all over a little bit. And so we'll plug these guys in here. So that's going to give me x naught plus delta x squared plus 8 times x naught plus delta x plus 2. That, ladies and gentlemen, is this piece right there. Then we need to subtract off f at x naught. Well, that one's not too bad. So f at x naught is just x naught squared plus 8x naught plus 2. So that's these guys right here. And then we're going to divide it by delta x. Okay, so let's go ahead and work this guy out here. So that's x naught squared plus 2x naught delta x plus delta x squared plus 8. I want to erase that. Let's do 8x naught plus 8 delta x plus 2 minus x naught squared minus 8x naught minus 2 all over delta x. Now at this point, things are going to cancel. So what cancels? Our x naught squareds cancel out, our 8x naughts cancel out, and our 2's cancel out. So we're only left with 2x naught delta x plus delta x squared plus 8 delta x. And we can fix it with that, right? So 8 delta x, and that's over delta x. Let me scroll down here a little bit, give us some more room. So we can factor out a delta x out of the top and the bottom. So that's going to give us 2x naught plus delta x plus 8 over delta x. And those guys are going to cancel out. So this is going to be left with 2x naught plus delta x plus 8. Now we have to let delta x go to 0. We've been doing that now, so we don't want that guy anymore because that's going to drop out, right? And all that we're left with is, now that we've let delta x go to 0, we've found f prime, the derivative, which is 2x naught plus 8. So what we want, we're not done yet. What we want is we want that guy to equal 0. So we want the derivative. Remember, this is the slope of the tangent line. So we want to know at what x values is it equal to 0. Well, that's pretty simple. We just go ahead and solve this. So we're getting a value of -4 out. Okay. Now we can go ahead and there's another way to find this same 2x naught plus 8, and that's using the formula that f prime at x naught is equal, if it's quadratic. This is only if it's quadratic. Okay, so again, a warning for you: if you apply this formula to something that's not quadratic, it ain't gonna work. So what do we got? We got 2 times a times x naught plus b, and our a value here, if we go back up to the beginning, our a value is 1, our b value is 8. Notice that the c value doesn't matter again because that moves the function up or down. So we've got 1 and 8. So we plug in 1 here. And we get this. So it's going to be 2x naught plus 8. So this and this match. Notice that this was a lot easier, and that the reason for that is because we already went through and we proved it in general using this whole long process. It's not magic, right? We just manipulated some symbols and moved some stuff around, and there we go. We simplified things. So we got this. Now again, we set this guy equal to 0. We get -4 out. So what does that mean? That means that when x is -4, up or down, who knows where it is? Probably down. Okay, and we can figure out where it is. Watch. If we take -4 and we plug it into x squared plus 8x plus 2, oh, maybe it's, no, it is going to be down. Watch. So this is going to be 16. Where did I get this stuff from? Right here. I just plugged in -4. What do I get out of my function? So that'll be 16 minus 32 plus 2, which is -16 plus 2, which gives us -14. So that means at -4 down 14, I've got the bottom of my parabola. And down here, the slope of the tangent line, well, what is it? It's 0. Okay, now that's how you do it with the derivative, and that's really probably the best way to do it. The other way that we can look at it is algebraically, and this would be something that you would have done in maybe a pre-calculus class or a college algebra class. And so here's how that works. We had a function f of x, right, is equal to x squared plus 8x plus 2. Now what we can do with this guy to find its vertex is we can complete the square on it. So we're going to go x squared plus 8x. Take this, now if it's been a while, here's how you complete the square. Okay, here's how you do it. You take the linear term, which is b. you divide it by 2, and then you square that guy. So for us, it is 8 over 2, which is 4, squared is 16. So we're going to add 16, and then we're going to subtract 16. So I haven't done anything, right? I mean, if you take this 16 and this negative 16, you put them together, you get 0, and well, we're back up to the original. Now, what does that do for us? Well, that says that, look at this guy right here. That guy factors out into x plus 4 times x plus 4. And so that gives us x plus 4 squared minus 14. And what do you know? This guy in here tells us the x value of the vertex. And this guy out here tells us the y value of the vertex. Hopefully you remember from doing parabolas that the general form of it is f of x is equal to x minus h squared plus k, where h and k are the vertex. So we do the opposite, because of this negative, we do the opposite of the inside, so we get negative 4, and the same as the outside. And that also gives you the same vertex value. Pretty cool.